So the first skill that we want to emphasize in this chapter is to show you how to convert between different units of pressure using your existing dimensional analysis skill set. So as our first practice problem, we want to consider that the typical atmospheric pressure on the top of Mount Everest is 265 millimeters of mercury. What is this atmospheric pressure if we express it in pascals and atmospheres? So in terms of our strategy, there's nothing new here. This is just a dimensional analysis problem where we have a pressure measurement that's in one set of units, and we would like to convert it to a different set of units. The relationships that we need to keep in mind are the ones that I just showed you on the previous slide. So 1 atmosphere is equal to 760 millimeters of mercury, which is equal to 101,325 pascals. 1 torr is equal to 1 millimeter of mercury. 1 bar is equal to 100,000 pascals. And these are the 5 basic pressure measurement units that we deal with. Therefore, if we consider that our initial measurement, remember in dimensional analysis, you always start with the measurement that has been made, is 265 millimeters of mercury, we need a conversion factor that will first take us from millimeters of mercury to pascals. And so definitionally, 265 millimeters of mercury is our original measurement. Our conversion factor is there are 101,325 pascals for every 760 millimeters of mercury. So a symbol of conversion factor with the number of pascals in the numerator, number of millimeters of mercury in the denominator, and we multiply and divide through. So 265 times 101,325 divided by 760 millimeters of mercury cancels with millimeters of mercury, gives us 35,330 pascals as our equivalent pressure. We go through the same thought process for atmospheres of pressure. We start with 265 millimeters of mercury, and we recall that there's 1 atmosphere for every 760 millimeters of mercury. And so if we divide the millimeters of mercury, and so if we multiply through, the millimeters of mercury divide out, 265 times 1 divided by 760, this pressure is equivalent to 0.349 atmospheres. Again, the millimeters of mercury and the millimeters of mercury cancel. And so considering significant figures, looks like we're entitled to 3 sig figs in our final answer. Our final answer is 3.53 times 10 to the 4th pascals, or 0.349 atmospheres. So again, this is not a new skill, but you need to get back to grips with dimensional analysis, because inserting your measurements in the correct pressure, temperature, and volume units in the ideal gas equation will be essential to getting the correct answer. So if you've been neglecting units in your calculations, get out of that bad habit right now. You will need to consider the units of your measurements to calculate properties of a gas correctly.